Welcome to the TNT Enrichment for Investigation 3. In class this week, we examined a few different relationships of variables that had this naturally occurring inverse variation. Today in the enrichment, I want to show you a couple more examples that have this inverse variation that you might not be aware of or you might find interesting. The first one that we're going to look at is the Teeter-Totter problem. Here we're going to look at mass and distance and how they are related to each other. First, you're going to obviously be watching this video. I'm going to have you go to this website, which I'll show in a second. I'll look at the relationship between distance and mass. I'll play around with that a little bit, try to get you to make a prediction here in number 2 about what the relationship is. And then I'm going to have you go back to the website, play around with the Balance Lab interactive app, and then once you have a decent enough idea of how the mass and distance on a teeter-totter is related, you can play 4 game simulations, either with your partner if your teacher allows or by yourself. So let's first go to this website. You can type this into your browser and go right there. This will end up coming up. What you'll have to do is click on the Balance Act play button. Opens up this tab. I'm going to show you the introduction to see if you can see the relationship, and then where you'll be going is the Balance Lab and then also the game. So let's go to the introduction first to see the relationship. It takes you to this screen. This is an app that simulates a teeter-totter. We do not need the upright supports, so we're going to just take them, slide that off. And then it would be nice to know the different distances from this centerpiece here, which is called a fulcrum. So let's put the markers on so I know how many units away my weights are. You should know how a teeter-totter works from back in elementary school. If I put a 5 kilogram weight on one side, I need to have the equal amount of weight on the other side for it to maintain its balance. But if I would take this weight off and put on a different size weight, you can see that it's not going to maintain balance, it's not going to stay level. So what I have to do is think about how the variables of mass is related to distance away from the fulcrum. Let's say I move my 5 kilogram weight to 8 units away from the center fulcrum. That means I need to change my distance with a 10 kilogram weight inward to get it balanced again. I want you to take a second and look at the distance these two are away from the center fulcrum as they're related to each of their masses. Let's try something again. Let's go to 6 units away from the fulcrum and move my 10 kilogram weight 3 units away, and I got a level teeter-totter again. Again, look at the distance away from the fulcrum and their weights. Let's move this to 4 units away. I need to move my 10 kilogram weight 2 units away and maintains balance, and then we'll do one more 2 units away. This would need to be 1 unit away. So take a second now, go back to your worksheet and make a prediction about what do you think the relationship between mass and distance are on a teeter-totter. Go ahead and pause this video now, write this down, and then come back to the video after you have made a prediction. Thanks. All right, you should have seen that the mass times the distance will be equal on both sides. This is an inverse variation because as the mass increases, the distance must decrease in an inverse way. This mass decreased, so the distance away from the fulcrum must increase. So you have one variable increasing, the other variable decreasing in a nonlinear way. What I want you to do next is go to the Balance Lab to practice this a little bit on your own. If you click on the Balance Lab, the same type of app simulation comes up. Again, you can take away the supports, add the unit markers on here, And I have a different amount of mass weights along the side that you can drag on and put wherever you would like. Try some of the different people out, throwing them on here and trying to balance them at different locations and different distances, as well as some of the mystery objects to try to guess at how much weight is potentially in some of these boxes. Drag them on and try to balance them, move them around until you get them to create a level beam. After you play around with this for a little bit and you feel comfortable about the relationship, go to the game simulations. There's 4 different levels, starting out easy and getting harder. And like I said before, go through it by yourself. The activities are timed, so you can potentially, if your teacher allows, try play against somebody to get through the levels faster than the other person. So go ahead and try this and come back to the TNT worksheet once you're done. Thanks.